Over the past year and a half, I've been interviewing many different engineering teams, over 50 different teams of different sizes, industries, countries, and also different roles, engineering managers, developers, to truly understand one specific thing, and is what are code reviews best practices. So first of all, why do I care about code reviews? So basically because I'm a developer and code reviews are a really important part of the software development process. And it's just that. So why code reviews are important? Basically because, well, most of the people, the first thing that comes to their mind from code reviews is that are important for guaranteeing requirements from all the stakeholders, right? Like guaranteeing security, maintainability, performance, functionality. And yes, code reviews are for that because, four eyes are better than two. But also, code reviews are super important to build culture in your engineering team. And what I mean by culture is how your developers, for example, think about prioritizing shipping features as a team, or writing code individually and finish their tasks, for example. Or also how your developers feel about accepting feedback or sharing knowledge in the organization. These are the kind of things I mean by culture. And code reviews are probably, I would say, the most important part of the software development process to build a great culture, because it's where most of the feedback is given, is where most of the knowledge transfer happens, even in the code base or how other developers are used to build things. It's also really important for onboarding new developers. So code reviews are super important for building a great culture. And also, code reviews, they are a big part of the software development process, and really they can impact a lot on software delivery performance. There is this report that comes every year, is the DORA report. DORA is the DevOps Research and Assessment Group from Google, and they do a report every year analyzing, what are the key factors that affect uh, software delivery performance. And one of them, the last year, one of their conclusions were that code reviews can accelerate software delivery performance up to 50%. This means that teams that have better and faster code reviews, they can ship up to 50% faster. So this is why they are important. Also, my personal experience as a developer while I worked for another company wasn't great around code reviews. All our pull requests got stale all the time. There was a lot of miscommunication on messages. We used to talk on Slack DMs or channels where there was people not involved in the pull request. It was quite a mess. So in this video, I'm gonna try to summarize all the things I learned over more than a year, actually, interviewing engineering teams around code reviews. So one of the things I know for sure about code reviews is that they need to happen fast. And why? Well, this might sound a little obvious, right? But it's super important that they happen fast, because most of the time code reviews are blocking, and this means that code is not going to production until the code review is done. And if code is not going to production, basically you ship features more slowly. And if you are an early stage company, it means that you have less chances to achieve product market fit. And if you are an established company, it means that, well, you improve slower the product and competitors may catch up, or you lose opportunities to have more revenue in other areas and other features. So shipping fast is important. And also, well, there are some alternatives on unblocking some of the code reviews. For example, with this method called ship show ask, where you basically have the conventional pull request and you wait for a code review to be approved before merging the pull request. But then you have, for example, the show pull request, where you code review the code after merging the pull request. And this is for changes that are really secure, but you actually want to get some feedback because you may improve the code later, or you want to show how you implemented this feature to a teammate and they can learn from it. And then we have the ship changes that are just basically changes to the main branch, maybe even without creating another branch. And these are for super secure and normally smaller changes, like updated documentation or changing the color of a button, this kind of things. And then we have pair programming. So this is also not blocking because you actually do the code review while implementing the code. And actually, I will talk about pair programming later. So the other reason for doing code reviews fast is because actually it's much more efficient. Uh, Imagine creating a pull request and getting the first code review after 2 weeks, 2 weeks after creating the pull request. You already forgot about all the changes you made. So you have to spend time getting back into the context of the pull request, and it's basically wasted time. So, what can we do to do code reviews fast? If we take a look at the software development process, we can divide it into different stages. So let's focus on these two, pickup time and review time. Pickup time is the time from opening a pull request until a reviewer is assigned to review that pull request. And code review time is where the proper code review happens, from reviewer assigned until a pull request is approved. So let's focus on these two because they are the most related to code reviews. So from in the process of pickup time, I've seen teams doing many different things here, like from grabbing the pull request link and dropping it into a team channel in Slack and hoping someone will review it, from using code owners to automatically assign reviewers based on the files changes of the pull request. Other teams always assign the same person as a reviewer. And also in Pulpo, we are thinking if implementing a feature to assign the best reviewers based on the on Git claim and the file changes of the pull request, and also on the workload of the team. So let me know if this is something would be useful on your team or not, and I will take a look. Also, then in the code review time, there are many things you can do here, like having automated checks with all your testing and using linters for doing the nitpicking, and even using AI to do a summary on the file changes on the code to give the reviewer an easy way to enter into the context of the pull request. And this is something we already do in Pulp, and you can try it out. But the most important thing here is to reply fast to code review messages and do the first review as fast as possible. And it's the most important thing for sure. And there are some tools here that can help. For example, there is the GitHub Slack bot that notifies you if someone comments a pull request you are involved and has reminders. Also, Swarmia has a different, similar Slack integration too. And also in Pulpo, the other day we launched in Product Hunt a Slack integration that also has the reminders and that, but it lets you create a temporal Slack channel dedicated to that pull request also. And this channel is connected to the pull request. Here is the AI summary I mentioned before. And for example, if you create a code comment in GitHub, it will go back to the channel with the context of the code that you commented. If you reply here in Slack, it will go back to GitHub. You can approve the pull request directly from Slack. Uh, And if you when you merge the pull request, the channel will disappear. So use the tool that works best for you, but reply fast to code review messages. So what happens if you are super focused on a task, but you suddenly receive one code review message and you are supposed to reply as fast as possible to code review messages, but should you stop what you are doing or should you reply to the code review messages? So there is one rule with code reviews, and is that code reviews shouldn't break your flow. If you've never heard about this term of flow state, there's this cool book called Flow, which basically explains it. But flow means this mental state where you are super focused, and it could be doing your favorite sport, but it could also be cooking, or it could also be working, and you are focused in your task, and time passes fast, and you feel super productive. So basically, this means flow. And the more time you spend there as a programmer, but also as a manager, or I think probably this works for other departments too. But the more time you spend there, the better. Actually, there are some frameworks of developer productivity out there that set the flow state as one of the key factors for driving developer productivity, as long with short feedback loops. For example, fast code reviews are also short feedback loops. Also, I don't know, fast build times, for example. And the other factor here is in this paper is cognitive load, which is the amount of mental processing developers have to do for performing a task. So the lowest cognitive load, the better. Um, so okay, we agree on that flow state is important, but for most people, getting to this flow state is not that easy. Typically looks something like this, where you spend some time getting into this flow state. There are some techniques that lets you go faster to there, but normally it looks something like this. So if you reply uh, all the time to interruptions like code review messages, like unexpected meetings, unexpected messages, your day could look something like this, where you are context switching all the time and never being focused on something specifically. And this is not good. And your day is basically ruined. So when should we reply to code review messages? Basically, when we are not in flow state, doing another task, I mean. And it could be at the beginning of the day, it could be after a daily meeting, before a daily meeting, before having lunch. There are many times in the day, during the day, that we are not in flow state and we can start replying all these code review messages, start doing all these code reviews that we have to do. And we should prioritize doing these things as fast as possible, as soon as possible to, finish the code review fast. By the way, this video is kind of a deep dive into this article I wrote in depth too. It's like a summary of the video, and you can check it out in the links of the description. Um, Back to the video. Another super important thing in code reviews is communication. And this is because normally, typically, unless you are doing pair programming, communication in code reviews are in a written format. And this means that your voice tone is not there, that your corporal movements are not there. And these two things give a lot of information behind the intention of your message. And this means that this and taking into account that you are kind of looking at someone's code, someone's creation, it means that misunderstandings are much more common. So there are some tools out there, such as conventional comments, for example, that were created to explicitly uh, express the intention of your messages in a written format. For example, if it's only a suggestion or if your message is a question. And this gives the owner of the pull request much more information about the intention of your message. Also, before we mentioned that, approvals with comments are a good practice because you are letting know the owner of the pull request that your comments is not blocking the pull request from being merged. And this is also something that conventional comments does. You can also set or specify if your comment is blocking the pull request because it's something it must be done before merging the pull request, or if it's just a suggestion and we can merge the pull request, there's no problem there. So this is a really great tool. Some other general advices here in communication in code reviews is that it's better to ask questions than doing affirmations all the time and being nice, having empathy with the other person, um, mentoring all the newcomers to the company, or that are less senior. And if something very important is that if you don't agree in a specific subject, first of all, don't take it personally. Listen, try to understand the other person. And it's much better if you discuss it in a call or in person where effective communication is much easier because, because the corporal movements, because the voice, you can have more empathy. Yeah, this would be my advice for having a good communication in code review messages. Another important thing regarding code reviews is that we should try to keep pull requests small. We've all seen this meme where 10 lines of code equals 10 issues, 500 lines of code looks good to me. I mean, and we know it's true because if we want to keep quality in code reviews with super big pull requests, they must be super slow. And if we want to keep speed, they are super low quality with a looks good to me message. And it totally makes sense. So small pull requests also drives less cognitive load to perform the code review. And as we saw earlier, cognitive load is one of these three factors that drive developer experience and developer productivity. Also, maybe you've heard about this book called Atomic Habits from James Clear. I totally recommend it. And basically, in this book, James Clear presents four laws of driving behavioral change for making better habits. And if we want to build an habit of replying fast to code review messages and doing code reviews every day, we want to make pull requests easier and we want to make pull requests more attractive. And also, if they are easier and faster, we will get the satisfaction of completing the code review earlier in the process. Also, by the way, the first law is making it obvious, and here we have all these tools for having Slack notifications of code reviews, such as Pulpo Slack channels. So, what happens if the task that we are supposed to do is super big and we can't fit it in a small pull request? It requires a lot of changes. So, here we have some alternatives. First one is pair programming, because if you are also co-reviewing the code while you are building it, it doesn't matter if you end up building a big feature because you are already reviewing it at the same time. And the other one is stacked pull requests. So the idea behind the stacked pull requests is that you divide the big task into different smaller chunks that are in a reviewable size, let's say around 400, 500 lines of code or less. And how do you divide these changes? So the idea is to making logic divisions. Like if you have a, okay, let's say build feature A, we can divide it in building the database migration, and then we create a dependent pull request from there of building all the API implementation and the handlers. And then if we have a mono repo and the front is also in the same repo, we could create a dependent pull request there for doing the front end page and the settings, and then we could do another depending pull request or stacked pull request for upgrading the I don't know, the documentation. So now we end up with different depending pull requests that are of a reasonable size, that they have one purpose, they are easier to review, and this has different advantages. First of all, we can start reviewing while we are even working in these other depending features. So if we detect improvements here, we can use those improvements also here and not wait until all the task is finished and waste a lot of time. So we can detect improvements earlier in the process, and also we can keep, reduce the cognitive load of reviewing pull requests and doing them faster. And there is, so when I post this, I got some interesting comments here, um, of some people saying that, hey, if I divide the pull request into different small slots, different small pieces, um, I can't see the whole picture, no, like the full picture. I can't test the code. I want to see the whole implementation of the full task. So um, actually, with a stacked pull request, you can do also that. So here in the last branch, you would have all the changes here in the same place. So you can, because all these changes are taken here. Um, so you could also review the final implementation in the last branch. So stacked pull requests are a great alternative. There are some problems because, for example, keeping the branches in sync may be difficult, because if you detect a change here, you have to, if you detect an improvement and change something here in the first branch, you have to propagate that change through all the different depending branches with git merge, for example. So it may be a little bit tedious and boring to do that. There are some tools like Git Down or GH Stack to automate having all the branches from a stack pull request in sync. We can use that to, make faster the process. So the last thing I wanted to comment in the video is some notes on pair programming, because along the video we mentioned many times pair programming, as a way to have non-blocking code reviews, also as a way for implementing big tasks without having to deal with reviewing super big pull requests, and also because, pair programming, when you are pairing, you have better communication because you are using your voice, or even if you are in a video call, your corporal expressions, your face expression, and it's also a real-time conversation. So communication is much better than written comments normally. However, pair programming doesn't work all the time for all the people, for all the kind of problems. And from the developers I interviewed, and also from my personal experience, it happens that it's much harder to achieve flow state sometimes while pair programming. And if you remember, flow state is one of these key factors in this paper we saw that affect developer experience and developer productivity. And also, if you are not in state, it also means that you are feeling much less productive and it's a less enjoyable experience. So it's not good at all. So, as a developer, you should learn how to detect good pair programming opportunities for you. And here, everyone is different. And it depends on, I would say, these three factors: the type of task, for example, hard and complex problems, or more creative solutions, um, or also the teammate. In my case, I feel productive, I feel in flow space if I am mentoring a more junior developer, for example, and also the pair programming approach. And there are many approaches here, and just try different situations, try uh, different tasks, different teammates, and learn what works best for you and where do you feel productive and where do you feel in flow state. So that's it for the video. I hope you like it and drop your comments below. I will read them all and reply. That's it, and see you in the next video.